Hello everybody, we're in our math strategy section of our SAT Math Level 1 prep course 2.1, strategies 3 through 4, or 3 through 5, 3 through 6, sorry, SAT Math strategies 3 through 6, and we have 30 points of notes that are available for you to take notes, or you can get a note-taking guide through that email. So, strategy 3, draw and mark up diagrams. So, feel free to mark up diagrams in the test booklet. And this is the way that you're really thinking by visualization of your thinking process. Solve a problem by drawing your own lines on the diagram. So, it's like doodling, and that's important, is to get your thinking out there. Example. No calculator section, multiple choice, diameter of the base of the right circular cylinder is 6, and the distance from the center of a base to a point in the circumference of the base is 8. What is the height of the cylinder? Here's your cylinder here. You have a diameter of 6. Here are your possible solutions to this problem. Add the altitude to the diagram and draw a segment that represents the distance from the center of the upper base to the circumference of the lower base. Here it is here. Here's your altitude or your height of your cylinder. Since the diameter of the base is 6, the radius is 3. So this will dissect your diameter here. And you have 3 as your radii. The height h of the cylinder is the leg of a right triangle in which the other leg is 3. So here's your height. Your leg here is 3. What's the hypotenuse? Use the Pythagorean theorem to find h. We know our hypot here is 8. H squared plus 3 squared equals 8 squared. And then we do our algebra here. H squared is 64 minus 9. H equals square root of 55. So our height here is square root of 55, which is about a little bit more than 7. So we have another situation here where we have a circle. In the figure, circle O has radius R. We have radius R that isn't seen. AB equals 3 over 2R. So it's 3/2 of the radii here, this chord. What is the distance in terms of R of AB from the center of the circle? So we want to know this distance here. How do we find that? To represent the distance of AB from the center of the circle, draw the length of a segment from 0, meaning here, and perpendicular to AB, which would be here or somewhere there. Also draw radius OB to form a right triangle. There it is there. So here is our right triangle here, and this is our radius here, R, from O to B. Since the line through the center of the circle and perpendicular to a chord bisects the chord, so BC equals 3/4 R, BC equals 3/4 R here. Mark off the diagram. So use the Pythagorean theorem to find OC. We're going to find this. So OC squared plus 3/4 R squared equals R squared. So we're going to find this here in relation to R. OC squared equals R squared minus 9 over 16 R squared. OC squared equals 7 over 16 R squared. So OC equals the square root of 7 over 16 R squared, which equals the square root of 7 over 4R. So that would be our here to that. Whoa, let me go back. I can't go back. So anyway, going further with our strategies here. Example, no calculator section, grid in. When a positive integer k is divided by 5, the remainder is 3. What is the remainder when 3k is divided by 5? So what? Okay. List a few positive integers that when divided by 5 give 3 as a remainder. Any positive integer that is the sum of 5 and 3 or of a multiple of 5, 10, 15, etc. and 3 will have this property. For example, 8, 13, and 18 are each divided by 5. The remainder is 3. So this is kind of like the thought process here. 8 plus 5 equals 1, remainder of 3. 8 divided by 5 with a remainder of 3 here. Then 13, remainder of 3. And then 18 with a remainder of 3. So these are possible candidates. Now using the same values for k, divide 3k by 5 and find the remainder. So k, 3k divided by 5, k over 8, 3k over 24, or 3k divided by 5 equals 24 divided by 5 equals 4, remainder 4. So 13, 39, and then 39 divided by 5 is 7, remainder 4. So 18, 54, and 54 divided by 5 equals 10, remainder 4. Now, using the same values for k, divide 3k by 5 and find the remainders. The correct answer is 4, actually. So that would be one way that you could do it. 24 divided by 5 equals 4, and then you have a remainder 4. Strategy number 5, make an organized list or table. Arranging the facts of a problem in an organized list or table can help you see and to make it easier to solve a specific problem. So example, no calculator section, multiple choice. If p and q are integers such that 6 divided less than q less than 17 and p over q equals 3 over 4. How many possible values are there for p? So these are the possibilities here for p. If p over q equals 3 over 4, then p equals 3q over 4. Since p is an integer, q must be divided by 4. Make a list of all the integers between 6 and 17 here. So we have these here. Divisible by 4. Then we have our list here of yes, no, yes. 7 and 16. Since there are 3 values of q divided by 4, there are 3 possible values of p. 3 possible values of p. That would be one way that you could do it, is by making a table here. No calculator, which expression is equivalent to I plus I to the 99th, where I equals the square root of negative 1. And then we have our list here of possibilities. To simplify I to 99th, list powers of I until you see a pattern. Here is our pattern for I. Furthermore, more patterns of I. And we just, we just go through this pattern. 1, I, negative 1, negative I, and then back to 1 again. And we just continue this pattern here of imaginary numbers, beginning with I to 0 equals 1. Consecutive integer powers of I follow a cyclic pattern evaluating to 1, I, negative 1, and negative I. The pattern repeats when the power of I is a multiple of 4. This suggests that large powers of I can be simplified by dividing the exponent by 4 and using the remainder as a new power of I. To simplify I to 99, divide 99 by 4, which gives 24, remainder of 3. So I to 99th equals I to the third, which equals negative I. Hence, I plus I to 99th equals I plus negative I, which equals 0. That is a cool way of figuring out what this will be. Calc section, grid in. The first two terms are order sequence. The positive integers are 1 and 3 of each number of the sequence after 3 is obtained by adding the two numbers immediately preceding it. How many of the first 1,000 numbers in this sequence are even? Write the first several terms as sequence until you see a pattern. 1, 3, 4, 7, blah, blah, blah. In the first 3 terms, there is 1 even number. In the first 6 terms, there are 2 even numbers. In the first 9 terms, there are 3 even numbers. In the first 999 terms of the sequence, there are 999 divided by 3 equals 333 even numbers. Since the 999th term is even, the 1000th term is odd. Hence, there are 333 even numbers in the first 1000 terms of the sequence. Grid in 333. And then that, my friends, was 2.1, lessons 3 through 6. Email me here for tutoring, worksheets, tests, quizzes, note-taking sheets, etc. Thank you.